Hi guys, it's Talha here again. So as I stated in yesterday's video that today we were going to discuss about sampling distribution, and here's the video of our uh, topic. That is, so yesterday we discussed about hypergeometric distribution and the uniform distribution that was for continuous variables, and hypergeometric distribution was for the discrete random variables where you have the dependent events instead of having an independent event that you have in Poisson distribution and your binomial distribution. So today our topic is sampling distribution. and after that we are going to discuss the sampling distribution of mean. And later in the videos, as we gradually study at the university the sampling distribution of different statistical values, then I'm going to make a video about that as well, about sampling distribution of many other statistical terms. So for now we are going to stick with this sampling distribution of mean. But first first of all, let's discuss what is descriptive statistics. So there are two types of statistics. You have descriptive statistics, and the second one is your inferential statistics. So in descriptive statistics, what you have is you have all the data about your population, about your sample space, about your samples, and you just make graphs, and you just make illustrations based on the information you get from these from the data which you have of these the population, sample space, etc. So what you do, you basically implement the information you get from the data, and then you illustrate it, and all the information you have from population, samples, and all the statistical terms, you implement it, and then you illustrate it in the form of a graph or any other kind of illustration. So that means you have all the information needed to illustrate a certain statistical term. But in inferential statistics, what you have, you don't have information about the population, you don't have the information about the total possibilities. So what you do, in inferential and from descriptive, as the name suggests, is to describe. Means that you have all the information, you just have to implement it and describe what your information is. But in inferential statistics, what you do, that you inference. So what is inference mean? Inference mean you guess. So you you make inferences about the whole population based on your samples and based on your sample space and samples. So what you have, you don't have any sort of information. So what you do, you take out certain samples from population, and then based on those samples you calculate or you make inferences about the population you have. So here the sampling distribution is basically related to your inferential statistics, because first discuss what is sampling. First let us discuss what is sampling distribution. So it's the distribution, as the name suggests, it's the distribution of the samples in the sample space, or is the distributions of the samples, certain samples, and then you apply the different distributions to them. So for example, there's a population, and you have certain samples inside. So let's say that you have 2, 3, and 4, and let's say 5 and 6. So this is 1, 2, 3, 4 and 5. So this is your total population. Let's say this is your total population. Now what you do, you make a sample space, or you take out the samples of size 2, n equals 2. So that means that in every sample there's got to be two elements in a single sample. So for example, I choose 1 3. So first let's take out the mean of this whole population. So how do you take out the mean? What we do is we add all of the terms. So we have 1 2 3 plus 4 plus 5, and divided by the total number of terms, we have 5. So what that is actually going to give us: 1 plus 2 3 3 plus 3 6 6 plus 4 10 10 15 5 divided. So this is going to give us 15 by 5 equals 3. So our mean so the total or the population mean is 3. But now what we are interested in is we are interested in taking out some samples out of this population. So let's say that I take out the samples of alright, so let's make it samples of 3. Okay, so the samples of size 3. So what does size mean? Size just means that you have got to have the number of size, what number you are given in the n. So that means there's got to be the same number of elements in your single sample. So let's say I take out a sample that is 1. From here I take out 1, 1 4 and 3. So let's find out the mean. So you add them all up. So you have 5 plus 3 5 6 7 8. So you have 8 by 3, and that is going to give you 1 2 2 point 2 point 2 point something, 2.7 something. So that so this was your population mean, and this is your sample mean, equals x bar 1. Let's say this is your first sample mean. Now let me take out another sample. So you have 1 3 2. So you add them all up, and then you divide by total numbers. So 3 plus 1 4, 4 plus 2 6, 6 by 3 equals 1 by 2, or 2. So this is giving you 2. Now let's like this you can take out, you gotta have to take out samples of size 3, all the samples in this population of size 3. So let's now discuss the as I stated that when you will take out all the samples from this population of size 3, what you're eventually going to get all of the sample means of all these samples. So at the end, what you're going to do is take an average, or you're going to distribute that probabilities, or you're going to distribute that sample mean, and eventually what you're going to get is your population mean. And the reason why it is related excuse me, so the reason why it is related with your inferential statistics it's because you're taking out the samples and you don't know. For example, let's say that you don't know what the population mean is, but you take out the samples, and based on those samples you take out sample means. You find out what their sample means, and then you take the average of those sample means, and eventually you get pretty close to your population mean. So let's say that first let's jump right to our sampling distribution. And also as I stated earlier, that sampling distribution is when you take out different samples, so this is the whole population. You take out different samples, and then you find the statistic of these samples. So for example, you find the means, or you find the range, or you find the standard deviation, or variance, for example, and then you distribute those statistical terms, and that is what it's going to give you. It's eventually going to give you that statistical term of this whole population. So what you're doing, you're making an inference about the whole population through these samples which you just took out. So that is why it's called sampling distribution, and that is how it's related with your inferential statistics. So sampling distribution of mean. So as I stated that, you for a sampling distribution of mean, what you're going to do is you're going to make a column. So here you'll have all the samples of your size. All right, so let's say it's going to be a little, it's going to take a while if I take out, if I have a population of 5. So let's say that I have a population of 3, of 3. So 2 and 3 and 4. So I am to take out the samples of size 2. So that means there's got to be two elements in a single sample. So what we are going to do is first this side is going to be all the samples which I can make from this whole population, and on this side I'm going to have the X bar, or the means of respective samples. So let's say our first sample is so size 2, so that is 2 2 2. So I can also repeat the same digits. I have 2 2, I have 2 3, and I have 2 4. The same way we have 3 2 3 3, and we have 3 4, and now I have 4 2 4 3 and 4 4. So this, all right, so first let's find the mean of this population first. So we have 2 plus 3 plus 4 divided by 3, that is equal to 2 plus 4 6 plus 3 equals 9 by 3, and it's going to give us 3. So the population mean is 3. Now let's find the sample means of all the respective samples. So we have 2 plus 2 4 by 2 equals 2. We have 2 3 2, so or 2 plus 3 equals 5 by 2. So it's going to give us no, it's a 2 plus 3 5 by 2. This is going to give you 2.5. So this is 2.5. This is 3. This is 3 plus 2 5. This is 2.5. This is 3 again. Yep, this is 3. This is 4 5 6 7. That's going to give you 3.5. 4 plus 2, that is again going to give you 3. 4 5 6 7 7 3.5, and 4, this is going to give you 4 plus 4, yes, so this is going to give you 4. So if you want to find the sample distribution of your sample mean, so what that means is you're going to find the frequency of how many times a certain sample mean is repeated. So here we have 2, so 2 is repeated just once. We have 2.5 repeated 2 times. We have 3.5 repeated 2 times, and we have 3 repeated 3 times, and we have 4 repeated 1 time. So that means if we are going to draw the graph for the sampling distribution of the sample mean, so it's going to be like this. So you have here for example, here you have 1, here 2, 3, 4 and 5. Here you have, so here you have 2.5, here you have 2.5, here you have 3.5, and that's it. 2, 2.5, 3, 2.5, 3, 3.5, and you have 4. So that means that 2 is just once. So 2, so that means that 2 is so the total probability is 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 total outcomes. So that means 2 by 9 is the frequency of this sample mean. So we have 2 by 9. So this is 2 by 9, and this is, it's repeated just once. Then we have 2.5. So 2.5 has 1 and 2.5. So we have 2. So 2.5 is actually repeated 2 times. So we have 2.5 plus 2.5. So that's actually going to use 5 by 9. So at 5 by 9 we have 2.5. So 3 is actually 3 plus 3 plus 3 equals 9. Yep, I think it's like this. So it's actually so 3 is repeated the most time. So we have 3 right here, and then 3.5 is 2, so it's like this, and 4 is just once. So what this is actually showing is showing the distribution of your so this graph is actually showing the distribution of your sample mean. This graph is showing you the sampling distribution of your sample mean. So earlier I explained that how sampling distribution is related with your inferential statistics. So how it is related is because you had a population. So for example, you didn't know what the population was, and we calculated the population mean. So there was 3. Now from the population we took out certain samples. We took out all the samples, and we took out the respective sample means, and then we found out that 3 is repeated the most time. So that means we can inference that 3, that right here we can inference that 3 is your so we can guess that 3 is going to be the population mean. So what we did, we made an inference about the population through your samples. So we can also find the sample means for your, or you can also find the sampling distribution. You have central theorem, you have central limit theorem for your sampling distribution. You have and you can also find your sampling distribution for many other statistical terms. For example, you can find it for variance, and you can find it for standard deviation. You can find it for range and many other statistical terms. And what that will actually do, when you will find each statistical term, then when you will apply each of them, when you will apply the distribution on, what it's actually going to give you an inference about the whole population which you had. Also, one important thing, that as your sample size increases, so as n approaches infinity, so what you're actually going to get, going to get a more normal distribution. So for example, you have a distribution that is not normal. So this one is pretty normal because it's going like this. So this distribution is pretty normal, but you have some distribution graphs which are not normal and which are pretty messy. But as your n approaches infinity, and as your number of trials or number of samples increase, as your number of samples and size of samples increase, your chances of getting a more normal distribution also increase. So guys, that was it about sampling distribution and sampling distribution of mean, and I also explained to you guys about descriptive and inferential statistics. And inshallah, I'll see you guys next week. Take care. Bye bye.